and I'm the National Training Director for Blue Earth Labs. I apologize, I've got a sinus infection and an ear infection. So I'm hearing you guys over on this side, and you guys are hearing me talking somewhere over here. So if I get a little disoriented, just throw something at me, okay? I've been in the water business about 38 years. I was everything from a public utilities director to a treatment operator. I started in the water plant, worked my way up. I've been a national director of sales for a couple of major chemical companies over the years, and I've seen a lot of horror stories. The gentleman did a great job showing you tanks. We're going to talk today not only about filter media, but we're also going to take the time to talk about biofilms and leaded water surfaces, because all of those directly have an impact on the amount of biofilm and chlorine demand that are in the system. So this is our take-home message today. We're going to talk about water quality issues and where it starts and how to protect it. We're going to talk about reducing contaminants in all phases of the process. Not only the filters, but the entire process. You know, every wetted surface has biofilm. You know, a really good demonstration of biofilm, you know that scum that you had on your teeth this morning when you woke up? Unless they were in a glass now. Just wait a minute. If they were in a glass, you probably didn't feel it. But if you ran your tongue across your teeth this morning, you felt biofilm. Okay? We're going to talk about optimization of the processes, different processes, and how they improve water quality. Of course, contamination on all wetted surfaces. Filtration media, it can be cleaned at a much less cost than replacement. Proper inspection and analytical data can save you big money. Cleaning processes take less time and money. And finally, distribution integrity. How many of you in here have heard of the EPA's Area-Wide Optimization Program, the AWOP program? Just a couple. Well, the AWOP program has a new program now that's specifically designed for distribution systems. You know, for the last 30 years, we've been doing a pretty good job in taking care of water plants themselves. Well, now the distribution system is the next frontier. So you're going to be hearing much more about area-wide optimization of distribution systems, because that's the next frontier for water quality. Okay? So let's talk about water quality. Basically, cleaning mechanisms from the raw water structure, whether it's surface water, well water, from the time the water is actually coming in contact with your piping system, you have the ability to control it. There's such things as downhole well cleaners now. The raw water lines themselves, just because they're in the ground doesn't mean that they can't be either physically or chemically cleaned to prevent contamination from getting into your water plant. So we're looking at systems now everywhere from this point all the way through the flocculation systems, the clarifiers, the filter systems, into the clear well tanks. Ladies and gentlemen, I have seen clear wells in the last 2 years that hadn't been inspected in over 40 years, some of them. Some of them still had the construction forms when the concrete was poured into them. They're out of sight, out of mind, aren't they? We know they're there. They're hard to get to. They're confined space. But they have issues. I guarantee you. So if you're not inspecting your clear well systems or any of these wetted surfaces to where you're having direct contamination being involved in your water process, you're causing yourself an issue. Not in the too past distant future, someone called and said they couldn't get any chlorine residual coming in on top of their filters. Well, we went out and they had to drain their sludge basins in about 6 or 8 months. Well, we did a sample. Obviously, bacteria was growing. They had a huge chlorine demand right in front of their filters. Anytime that you have a demand, no matter where it's at, you have the ability to clean it. And if you don't clean it, then you're causing yourself a problem that you really don't need to. Did you know the water plant should be the second cleanest facility in a community? What should be the first? The hospital. Actually, the water plant, you can actually hurt more people in a shorter period of time than what the hospital can. Not only that, when the doctors have a malpractice, they don't have to put that in the paper. But if we have a violation, it's got to go to the paper, right? So there's another reason that those systems need to be kept clean. So all the way through the system, we have the ability to change what's going to happen as far as contamination goes. These biological and mineral deposits, as they're being fed into the system, the amount of chlorine or whatever disinfectant that you're feeding, the residual starts high here. I'm sorry, that's into that header there. The chlorine residual is normally always high. As it goes out into the distribution system, and at these points of your point of entry sample, your farthest point samples, all of these are a direct relationship to the amount of contamination that's being come into contact with your disinfectant prior to entering the system. And as it enters the system, and as it makes its way down. That's why we harp a lot about time and temperature in the storage tanks. All of these are direct correlation. Because of the residuals, the disinfection byproducts go up, the chlorine residuals go down. This is nothing new. You guys have heard this all before. The thing that you haven't heard is clean your systems. Do you drive your car 3,000 miles and change the oil? If you're smart, you do. Would you go 6 months without cleaning your vacuum cleaner out? Would you go 3 years without changing the filter in your home, your air filter? No, this is a cleaning mechanism. It will operate better if you clean it. The disinfection byproduct rule and the stage 2 long-term surface water rule are two of the primary reasons that cleaning is important. The long-term surface water rule says that you have to maintain a minimum chlorine residual in the farthest parts of your system. Okay? Now that might be a consecutive system that you're selling water to your neighbor, or that might be your own system. Well, on the flip side of that, the disinfection byproduct rule says you don't need to feed any more chlorine than what you absolutely have to maintain that residual. So those two rules are butting heads. What happens is over a period of time, because the system quality starts breaking down, that chlorine demand starts getting higher and higher out in the system. And in order for you to maintain that 0.2, you might have to feed 4 parts per million is the maximum MCL for chlorine. I can't tell you how many systems I see that have to feed the max chlorine just to get a 2/10 residual out in the system. You know, one of the best things about my job is I see water plants literally all over the world. I'm getting ready to go to a country called Burma. Anybody know where that's at? Go to Thailand and turn left. So I see water plants literally all over the country. I was in the oldest filtration plant in America, which is Poughkeepsie, New York. It was designed in 1869. You know, that's when we were still, just kind of right out of the Civil War. I mean, think about that. That's a long time we've been filtering water. Technology has not changed. Basically, we have always known in order for water to be clean, we have to clean it up. We have to keep it clean. We have to clean it and continuously keep it clean as it goes through the systems. Did you know one of the very first regulations that had to do with water quality, you know what it was? It was to change the stagecoach cups at each of the sites where the stagecoach stopped. That's because they didn't want to have typhoid on the East Coast and get it to the West Coast. It's a cleaning mechanism. Nothing hard about this, it's just simple. So these standards, all the utilities are going to have to meet. By October of 2013, even the small systems are going to have to be in these regulations as far as disinfection byproducts go, and long-term surface water rule as far as benchmarking your chlorine. So if you don't know about that, now's a really good time to start learning, because October of 2013 is going to be here before you know it. Again, these two rules, they butt heads. One says to add more disinfectant in order to get your disinfectant throughout the system. The other one says to feed less because of the disinfection byproduct rules. So, how are utilities going to be able to do that? What they're going to have to do is they're going to have cleaning mechanisms. These cleaning mechanisms will allow for the water quality to be improved. Now, what has more surface area than anything that you deal with in treating water? This is an interactive question. What, sir?
Filter.
The filter. Because of the surface area size and the amount of volume of cubic feet that the water comes in contact with, the filter is probably the most square footage that the water comes in contact with at any given time. Now that might be, City of Houston's 24 million gallons at their 3 plants. Their filters are as big as this room. They're 2,080 square feet each. That's bigger than some homes. So the filters are a very, very good source of contamination. Okay? They're doing what they're designed to do. They're taking out impurities, they're taking out contaminants. But at the same time, the water's coming in contact with them a whole lot. So these cleaning solutions are designed specifically for cleaning all the wetted surfaces. Okay? The approach that we have is because it's economical and less time-consuming than taking media out than cleaning. The same thing with one of the reasons that you guys like to do inspections of your water storage tanks with divers is because it's more convenient, it's easier, but it's always necessarily the right way to do it. Not necessarily. Depending on what's in there. We'll spend some time about that. So let's look at some of the applications. Filter bays and troughs, granular filter medias of all different types, whether it's granular activated carbon, green sand, anthracite, garnet, support gravel. All of these mechanisms can be cleaned. Air stripping towers for iron reduction or VOCs, depending on if the well supplies have been contaminated with trichloroethylene or worse. Distribution systems and biological removal out in the system. Let's look at some of these surface cleanings. Ladies and gentlemen, if you see this type of material on your filter walls, if it's on any of your wetted surfaces, where the water comes in contact with either a basin, your troughs, the filter media, if it's there, it's on your media. Basically, because of the design of the system, it's coming in contact with the media. And you can see some before and after pictures there of spray-on applications. Does that have chlorine demand? You got to shake your head like a little dog in the window. It has a chlorine demand. It has a direct chlorine demand based on coming in contact with the water. It's got organic and inorganic material in it, therefore it has a chlorine demand. So in order to do a great inspection of anything, in order to really see what's going on, especially if it's concrete or painted surface, if you have those types of buildups on there, you're never going to be able to inspect it to see if it's really in good shape or not for the coatings. Some more pictures of filters before and after. This actually is in Hawaii. Next time we go take pictures, if you guys want to go, let me know. Before and after, you can see the buildups that are on here. This is Greensboro, North Carolina. There's 24 of these filters. Huge difference before and after. Not only visually, but also mechanically operation and chlorine demand. Every one of these systems cut their chlorine demand and their pre-oxidant demand by having these systems clean. I'm not telling you guys anything you don't know. Does your mom tell you to wear clean underwear? If you have an accident, you know you want to have clean underwear. If after you've had an accident, you may need to change it, but at that point in time, this is nothing new. This is just cleaning is all it is. So before and after show you a big difference. This particular one, they are utilizing ferric chloride in their process to reduce TOCs at a very, very high rate. They're doing enhanced coagulation. So they're taking the pH down to 5.5. to break the dissolved organic carbon, the DOC, out in order to precipitate it and make it come out. They are loading that system up with so much iron that any little pH swing that they would get, they get dirty water going through their filter. So once a year now, they go in and they clean their system. And that keeps it from happening. Okay? 84 million gallon a day plant, huge plant. So let's talk about the filter media. Everybody know this little term ROI, return on investment. If you're backwashing too much because you got high head pressures or you're getting short filter runs, increased turbidity, breakthrough, high chlorine demand, any of these issues, mud balls, cementing of the filters, they all cause operational issues that cost you money. Okay? It has a payback. If you're backwashing your filter once an hour and it's costing you 100,000 gallons of water every time you backwash, that's a huge amount of money. I just came from one up in Greenville, New Hampshire. That's what they were doing. They can only get about 3 or 4 hours runtime out of their system. So they were having a backwash every 3 to 4 hours. The problem was they had fed so much coagulant for so many years that it had just basically entirely covered the media and they could get no water through it. It had aluminum oxide built up on it, aluminum calcium carbonate built up on it. This media will encapsulate, which I'll show you some pictures of that. But anyway, this all has a return of rate on investment. Here's some different filter medias. Of course, granular carbon, anthracite. This particular picture is coming from a lime soda softening plant. This particular one is the sand from that same location. It doesn't take a rocket scientist, ladies and gentlemen, to realize that that media is dirty. And people will look at that and they'll say, oh, we just need to change it. We just need to change it. It's rounded. Well, it's encapsulated. What happens is the organic content in the water, the scale that builds up the calcium, magnesium, and the organics bond together. The organic is the glue that holds that together. It encapsulates around that media, and it does look like it's rounded. It also looks like it's more dense, which it is, and it also looks like that it might just be worn completely out. But until you actually do an analytical profile on that, you're never going to tell if that media really doesn't look like that right there, which looks brand new. The same on green sand. Now, green sand is obviously much, much different application because you're doing an exchange process. You're exchanging an oxidized material like chlorine or permanganate to exchange it for an iron molecule. Okay? But what happens is, even though the exchange rate is still there, it gets encapsulated with this material built up into these, well, lack of a better term, into these spores. I like to think of it like broccoli. Kind of gets covered over. You put the cheese sauce on it, well, you can't get the salt down into it. Okay? You kind of want to make sure that it's not really covered up, but it's still got an exchange capacity. So by cleaning it, you increase the porosity of it and increase the exchange capacity of it. Okay? So these materials can be utilized to clean green sand as well. And we've literally done hundreds of them. To date, Blue Earth Labs has cleaned well over 1,280 water systems all over the world, all their filters. So we've got a pretty good handle on all different types of filter media. So let's look about the tanks and the basins and why they're important. Obviously, because of the surface deposits and the sediments, they again can cause high chlorine demands. During the summertime, your chlorine is always going to dissipate because of heat. Time and temperature are two of the worst enemies that you have as far as maintaining your chlorine residuals or your oxidant residuals, whether you're on chloramines or chlorine. So, why give them food? If you don't clean your systems out and take care of the microbial growth that's going on in your systems, you're giving them food. Okay? And these biofilms, because of the nitrification process that's going on out in the distribution system in low flow areas and in dead ends, this food source is being built up. It is a direct chlorine demand. So in other words, if you're having problems maintaining a chlorine residual out in a certain area of your system, we've got a distribution map here in a little bit we're going to look at. What's one of the first things you do when you have low chlorine? Say it again, sir. You go flush, don't you? Why do you flush? To bring fresh water into it, okay? To try to move that stagnant water out. You've reduced your detention time in that portion of the system. Well, see, there's a lot of other things going in at that same time and going on, not only chemically, but also mechanically. Corrosion, nitrification, high HPC counts, elevated trihalomethanes, HAA5s, which are getting ready to go to HAA8s, by the way. Okay, we're going to increase the number that you're going to be testing for. Increased turbidities, inefficient inspections, deterioration of the surface coatings. These are all reasons that you want to clean that system. You want to get it out of there. You want to clean it out the best that you can do it and maintain it. You want to clean it and keep it clean. We have some products that can be fed directly to the distribution system. This particular product for potable water is called Claritas 101. It's potably approved, and it actually is a scale remover. And at the same time, it reduces disinfection byproducts by reducing chlorine demand out in the system. So over a period of time, we can clean piping up. Okay? Now, it's like anything else. It takes time to do that, and it takes flow of water to do it. But there are mechanisms to do this online. I know you guys heard about ice cracking this week, which is another way that you can mechanically remove scale and buildup in a main. There's lots of ways to do this. The way that you want to do it, though, is the way that's most economical for you, and you get the biggest bang for your buck. We feel like doing this and helping water quality is a much quicker turnaround and ends up costing less money to do it. But there's several mechanisms to clean it. Hey, as long as you clean it, I really don't care, because it's going to improve the water quality, and that's what this is all about, is improving the water quality. So, cleaning the distribution system has an ROI also. Does it cost money to pump water? Yes, it does. Electricity costs are going up and up and up because of the fuel. Anybody see diesel this morning? $4.30. Yep. It's going. It's going to be $5 or $6 a gallon here before the end of the month, probably. So, by removing scale and film in the system and stabilizing the disinfection residuals, any time that you can feed less chlorine, that ought to be one of the things, the disinfection byproduct rule. Okay, we have to live with it. It's here. We've been talking about it for years and years and years. Well, the time that it's been promulgated and it's coming down, how many of you like to post it in the paper that you've been in violation? Nobody in here should raise your hand. Does it cost you money? Yes. Does it cost you a sense of, well, the state thinks we don't know what we're doing, the city thinks we don't know what we're doing, the consumer thinks that we know not what we're doing. That's why bottled water sales are as high as they are. That is just convenient. So you want to make sure that you're doing the things that you know to help yourself out. The number one thing that you can do to help yourself on the disinfection byproduct rule, it's not going to chloramines, it's not putting GAC in your system, it's not putting ozone in, UV, it's not putting tank mixers in. You know what the number one thing you can do is? Reduce your chlorine by cleaning your system. Yeah, just remove it and clean your system. It's going to help. It's that simple. It's almost too simple. By eliminating the microbiological, what's going on in your system, you're going to improve your corrosion rates. You're going to improve your water quality. less fluctuation of pH, less taste and odor complaints, less dirty water complaints. All of those things can be tied directly to distribution management. This is a list of the AWWA concerns and focuses. I'm in a watch group with the AWWA and American Water, United Water, some of the major water utilities in America. And this is kind of what they think are some things that are really going to impact the distribution system and the distribution rules. And let's look at these. Cross-connection and backflow prevention. Obviously, if you don't have a backflow prevention and a cross-connection program, by now, you're in a world of trouble. Because you're supposed to have had it for years. Start implementing it and start making sure that it's working and the people in your communities are doing what they need to do in order to make sure that those backflow preventers are working. Contamination from main installations. Guys, I told you I've been there. Hey, now I was born in North Carolina. I live in Kentucky. We have cottontails down there. Every now and then, one would run in the pipe. You know, when we're laying pipe. That didn't mean that you left them in there, but they'd be in there. Luckily, I had a couple of beagles I could send in there after. You know, if a rabbit runs in there, you want to get him out. Do your main installations the way that they should be done. Have a specific standard operating procedure written down to make sure that there's no contamination getting into the mains as you're doing work. My goodness, how hard is that? Contamination from intrusions, pressure conditions, physical gaps. Make sure that you have your loading stations that are set up right so that you're not getting backflow from farm areas. You know, it's great to sell farm water, but make sure that you got an air gap so that they don't throw the hose over in there and they're mixing fertilizer in the tank. Okay? It's real simple. It's just simple stuff. These are the ones that are really going to start hitting home. The significant biofilm and microbiological growth and the lack of control in the distribution system. Nitrification issues that lead to public health effects. The nitrate levels have already been reduced from 45 to 10. Nitrates are going to be something that you're going to hear more and more about. Accumulation and release of contaminants from the distribution system from scale and sediments. Ladies and gentlemen, the infrastructure in America is old. I was in Portsmouth, Maine. You folks don't know what old is here in this part of the country. I saw houses that were built in 1684 that still had original water lines in them. The infrastructure in America is old. It's out of sight, out of mind. It's like the clear wells. It hadn't been looked at. We only fix it if it breaks. Naturally, it's going to be the next place that water quality is going to be looked at. Because we just can't hardly do any better than what we're doing at the water plant. Water plants are doing a good job. The majority of them. That's a buzzword you're going to hear a lot about. Biofilm. Now, every time you see that word, you're going to go like this. Yeah. I remember Bob said that's what it was like. Biofilm. This particular clear well, they couldn't get any residual of chlorine. They were losing 84% of their chlorine from the bottom of the filter to the first sample. And they said, we can't figure it out. Not only that, our trihalomethanes were double from the bottom of the filter to the first tap. And they said, we can't figure out what's going on. I said, I know what's going on. Clear well's dirty. Oh, we have never even looked at it. It's got an underground spring, and if we drain it, then it might float. We've been afraid to go down in it. I said, well, I guarantee you better go down in it and look at it. Well, they sent a diver in first, and then they saw all the wood from the construction and 2 or 3 piles of sand where the filters had breached, and they figured out they better clean it. So they found a way to drain it. If you haven't looked at your clear well in 38 years, I'd say it's time to start today. I don't think that you should go to sleep tonight until you look at it, frankly. Because they don't have it in there. That's what it should look like, clean concrete. Just some before and after pictures. How many of you do tours at your water plant? The school kids come in and they say, "Ooh, we're drinking that." Don't they? I've been there. I know. Your water plant ought to look like a showcase. You ought to be able to eat off of the floor in any room in there. It's public health, people. Would you eat at a restaurant that was nasty and filthy? I don't know, going to Burma where I'm going, I might. If I can find one that's not like that, I'll probably be in good shape. When they say chicken on a stick and it's got 4 legs, I'm afraid. Okay? Let's get back to filter media. Because the filter media comes in contact with the water in such a huge surface area, doesn't it make sense to look at it? It costs very little money, about $350, to have a complete analysis done of the media, to determine the constituent buildup on it, what the shape of it looks like, what the effective size and the uniform coefficient of it is, to see how close it is to specification. You ought to be looking at your filter media a minimum of every 3 years. Even more if you have real high swings on your turbidity or issues with the treatment plant, operation, short-circuiting, things like that. You ought to be looking at it a minimum of every 3 years. If we can clean it for about 30% of what it costs to replace it, hey, that's saving you money. You spend money on doing something else. I'd rather see you spending money on cleaning the distribution system than to just, throw it away in the landfill. Here's some stripping towers. Before and after pictures of being cleaned. Any wetted surface that oxidizes is going to have organic and inorganic buildup on it. And the longer that you let it go, I've literally seen these. In fact, I'm dealing with one now in Dayton, Ohio, that they have to have a jackhammer to get those balls out of there. My grandkids think they're wiffle balls. I had 2 or 3 of them at the shop. They said, "Where's the bat, Hawkins? We play ball." They thought they were wiffle balls. They do kind of look like that. It's just cleaning. That's all it is. Storage tanks. San Antonio, Texas. This particular tank was actually pressure washed to be cleaned out. And they couldn't even get all the staining and the material off of it. The point that I'm going to make about divers, they have a legitimate niche in what they do. Okay? If you need to look at a coating, and the coating is brown and like this, and you cannot inspect that tank until it's clean. The other thing is that's got a chlorine demand. Okay? Getting off the sediment on the bottom of it is a good idea, but it's only partially doing what it's supposed to do. But there again, some people just can't take them down. I've got one that I'm dealing with right now. They've only got 1 tank in town, and it's the only pressure source that they have. So they literally can't drain it. Not at all. So there's times that may be the only way you have to do it. But until you can get down to the coating, you really can't inspect it. Problems in the distribution system, you're always going to have corrosion and scaling. In water treatment, it's kind of like walking down a fence. You're one side, you're on the corrosive side. On the other side, you're on the scaling side. There is no water that's 100% neutral. So it's our job to put it in a economical way and treat it. It's either going to be scaling or corrosive. Now that's up to the water professionals to determine which one that's going to be. But don't just not treat it for the sake of not treating it. You need to know where you're at and then treat it accordingly. Here's the biofilm scenario. This biofilm starts forming in just a matter of seconds. It's in every water. It takes up to 250 parts per million to kill it. What happens is, the longer that it stays in contact and the time and temperature as this water starts moving through the system, in just a matter of hours and days, the bacteria starts to grow, and what happens is it forms polysaccharides. And these polysaccharides are sugars. And what they do is they lay down a molecular structure on the piping or the coating, and it kind of like weaves its way in there like cloth. and you cannot get it off. It has to chemically be cleaned, is the only way that it's going to come off. As it starts sloughing off and dying over a period of time, that's where your nitrification comes in, ammonia starts being released. You know, they're just having a party. It's kind of like going to a tailgate. You know, eventually, they're just going to start dying off. And once they start dying off, your chlorine demand's going to go up. You're going to spike on dirty water. This is the reason that biofilm is going to be something you're going to hear a lot about. Distribution woes. This is actually coming out of a clear well that was being cleaned. Of course, I hung out of helicopters in Vietnam doing search and rescue and pararescue, and I would rather have done that than to go in to a city council meeting where I've ruined 50 women's laundry. You know what I mean if you've been there. Okay? And no, this is not the definition of tank turnover. It really is not. That's actually one that collapsed because the engineering people decided to leave the bridge off of it, but it was actually a structural support. When they filled it up, it crashed. You need to be doing management of your distribution system. Okay? Otherwise, you're going to have these kind of problems. It's cause and effect. Whatever you do on one end affects the other. Get your water plant or your water source as good as you can get it. Get it as good as you can get it, and then start working on that distribution system to start getting that water quality the best that you can get it. Because naturally occurring matter is out in the system, you're going to see things like this. I can go in anybody's water system in the world, not just in America, but in the world, and find that. Find biofilm. It's in there. Because everybody's got dead ends, everybody's got short circuits. Know your distribution system. Know what's going on in it. Know areas that need to be cleaned better than other areas, depending on what your pressure zones are. This is your new frontier for water quality right here. Right here. Because this is where all the NOVs are going to come. 46% of the people in the United States are going to have an issue with stage 2s. That's almost half, people. This half of the room over here, you guys, I got bad news for you. You're all going to have trouble. You guys over here can skate for another year till the HAA8s come in. Okay? That's kind of the way you got to look at it. You're going to have problems. So be proactive. Clean your systems up. Don't wait till the day before the regulation comes into effect to start. Okay? Cleaner's better. Anytime you can maintain something, it's going to work better. Be a compliance hero. Our friends at Hawkins, they're our distributor here. They got, I've been up here. This is my second year, and I haven't won that 4-wheeler yet. Can't figure it out. But I have to come back. Team up with people that know what's going on. Because it's not what you know, it's knowing where to find what you need. There's a bunch of smart people. And none of us are as smart as all of us. You understand that? There's people in here that are very, very smart. A whole lot smarter than I am. But if we took this group collectively, if I could have had this whole classroom of people when I went to Indonesia after the tsunami hit, that big 90-foot wall of water, I could have had the water set up over there much quicker. Because there's a lot of technology and a lot of brains in this room. So don't ever think that you can't do it. Find the people that help you do it. Okay? Benefits of the cleaning, less chlorine. Less chlorine, less oxidant, less oxidant. Always think that. It's not what you know, but knowing where to find what you need. My time is just about up. Questions?